This is Lab 5, Choose Your Own Adventure. I chose my adventure to be that of the human rocket. The objective of this lab is to put all of the knowledge that I have obtained over the course of this class to work while analyzing the freefall of Felix Baumgartner, an Austrian skydiver who attempted and succeeded in breaking the speed of sound. For this lab, I will incorporate pre-gathered observations from cited sources and Python programming language to model Felix's freefall. I will use Newton's second law to help me prove if Felix did in fact break the speed of sound, and I will also use the energy principle to better understand the energy components involved within Felix's freefall. As for the main result of this lab, the model and observations together prove that Felix did in fact break the speed of sound and energy is conserved. The speed of sound is 290.57 meters per second when Felix dives through the stratosphere, where he reaches a speed of 3,557.63 meters per second. Some minor background information on Felix's freefall: he is taken higher and higher into the atmosphere within a capsule attached to a large balloon until he reaches 128,100 feet. He then jumps from the capsule back to Earth. Here I observed that Felix's freefall has three parts to it. The first part, which lasts 50 seconds, is when Felix is free falling through the stratosphere without drag force. The only force acting upon Felix is a gravitational force. The second part of his freefall lasts from the 50 seconds until 4 minutes and 20 seconds. Here is where Felix approaches the atmosphere and drag comes into play. The final and third part of the freefall is after Felix releases his parachute. It takes Felix 9 minutes to reach the ground. The parachute creates a large amount of drag that will help Felix decelerate steadily until he reaches the ground. Some more observations that I obtained from cited sources below. The weight of Felix, including the gear he used to freefall. He jumped from rest at 39,044 meters. Approximated, the speed of sound during the first part was exceeded by Felix when he was traveling through the stratosphere without drag. It isn't until the third part of his fall when the speed of sound catches up and he is decelerating to return to the ground. The speed of sound is a function of temperature, and sound travels faster in the warmth versus cold. On the other hand, you can say that Felix's speed is a function of drag in a sense, and atmospheric pressure. He reached his maximum speeds outside of the atmosphere in the stratosphere. Some fundamental principles. Newton's second law, where the final velocity equals the initial velocity plus the net force divided by the mass divided by delta t. There is the weight force in the first part of the freefall, where weight is equal to the mass multiplied by the acceleration due to gravity. Then we have the drag force, where there's a drag constant multiplied by the velocity. Finally, we have the energy principle, the conservation of energy in particular, where the change in energy is equal to the final energy minus the initial energy. Now I've incorporated observations into Python language in order to visually model Felix's freefall. Here I have the initial conditions highlighted in yellow, the mass of Felix's height above Earth, the time starting at rest, as well as the gravitational constant g, and j hat that will choose the positive y as up direction. For part 1 of the freefall, I put the time in as less than 50 seconds. I coded Newton's second law and the weight force, which would be the only force during this part of the freefall. For the second part of the freefall code, I highlighted the changes. Here is where drag force comes in, so the b constant is specified. Here it's 11. The time has changed here, and of course the net force is weight plus drag. For the final and third part, the b has changed greatly since this is where he opens up his parachute, so now it's 240 in order for him to get to the ground, and there's a change in time. I will now show the Python animation. In the video, you saw that the blue ball represented Felix, and he was falling towards the ground, which was a little tiny yellow ball. The yellow arrow represented the downward gravitational force on Felix, and the blue arrow represented the upward drag force that comes after the 50 seconds. Here I have outlined boxes of the different parts of the freefall. The first part in blue is where he accelerating until he reaches maximum speed. The second part is where there's a constant slope, which makes sense because he is no longer accelerating due to the drag force. The green outline refers to the third and final part of the freefall, which encounters a greater drag due to the parachute, and is decelerating until he reaches the ground. Here, finally, to prove that Felix broke the speed of sound, I changed my Python code around to only show the first part of the freefall, and to print out the maximum speed of Felix. I've outlined the max speed here, and it is larger than the speed of sound at that point in time. Now for the energy that takes place in Felix's freefall. As Felix freefalls from rest, his gravitational potential energy is converted to kinetic energy. By the conservation of energy, we have that total energy is equal to the final energy minus initial energy, or in other words, energy is conserved because the final energy is equal to initial energy. Felix's potential energy is obtained through mass times gravity times height, and the kinetic energy is obtained from 1/2 times mass times velocity squared. Some fun facts. Felix set 5 new world records from this 128,100 feet high freefall. Yay for Felix, and yay for physics. Thanks for watching.